So welcome to Linear Integrated Circuit Laboratory. Today we are going to see the simulation of Wein bridge oscillator. So as we have seen in the theory class, oscillator is nothing but without any input the circuit will produce a sinusoidal signal which is called an oscillator. We have different types of oscillator, not only sinusoidal signal, it also produces spire waves which is called multivibrators. So we have two sinusoidal oscillator which is Wein bridge and known as RC phase shift oscillator. For oscillator there should be a one condition, circuit should satisfy the one condition which is called Barkhausen criterion, we have seen already, that is A beta feedback factor into gain, and that should be equal to 1. So we have designed a Wein bridge oscillator for the frequency, it produces the output frequency of 5 kHz. So when you see the circuit diagram here, this is the Wein bridge oscillator circuit diagram. Without you see here input side, we will not be giving any input signal, but it produces output voltage V0. So because there is a noise factor which exists in the circuit. Each component, because of that, each component will start to tend to oscillate, and when the circuit satisfies the condition A beta equal to 1, it start to produce an sine wave. So we will check with the multisim whether it produces 5 kHz signal. So this is the circuit as we have seen. We have connected as per the diagram. So I have connected oscilloscope at the output side and double click the oscilloscope. I have got a sinusoidal signal, perfect sinusoidal signal. Now I should measure the time period of this signal, and from that signal we calculate the frequency, which should be approximately 5 kHz. So you keep it both the spike you fix for one period of cycle of this signal. So I have got here this one start from positive and then this yellow spike ended at negative. So the one cycle time period is T2 minus T1 is exactly to 19.697. We can take it as 220 microsecond. So 220 microsecond. Time period is 220 microsecond. So from this we need to calculate frequency. So here the time period is 220 microsecond, that is into 10 power minus 6 seconds. I need to calculate, if I want to calculate F, then 1 by T. So 1 by T. So if you find 1 divided by 220 into 10 power minus 6, then you will get approximately 4,545 Hz. 545 Hz, which is equal to 4.5 kilohertz. 4.5 kilohertz. This is approximately equal to 5 kilohertz. So we have got the output signal as per our design, 5 kilohertz signal. So this is how we need to simulate the oscillators. So we have one more oscillator which is RC oscillator. You check RC oscillator So output which produces so how many how the frequency of signal, you find out the output frequency of signal as per our design. Thank you.